Welcome to Energy Talks, a regular podcast series featuring expert discussions on power system testing, data management, cybersecurity, and important trends in the power industry. My name is Scott Williams from the podcast team at OMICRON, and I will be your host. Hello, everyone. In previous episodes of Energy Talks, we have spoken with experts about the benefits of performing partial discharge measurements and monitoring on electrical equipment. Partial discharge is also referred to as PD, and the measured presence and, most importantly, the level of PD activity is a good indication of the current and future health of equipment insulation. It is also a reliable way to detect developing insulation defects that can cause equipment failure, unplanned, and costly outages. In this episode, I speak with Daniel Gebhardt, who is an OMICRON PD expert and PD Monitoring Solutions product manager. Daniel has gained a lot of experience in both PD testing and PD monitoring from his previous roles as a field service engineer and an OMICRON Academy instructor, teaching power system testing engineers about PD measurement and monitoring, how they are performed, and helping them solve PD-related issues in the field. I will ask Daniel to describe the various methods of performing PD measurements and monitoring, their benefits, the types of information they provide, and how they are used together to determine the installation condition of assets. Specifically, I will also ask him to explain why there is a growing trend of performing online PD monitoring and online diagnostic PD measurements to determine installation health while electrical assets are in operation. Lastly, I will ask Daniel to describe how the use of a terminal box supports this growing trend of performing online condition assessments of electrical assets by enabling testing engineers to safely and easily connect PD measurement and monitoring equipment to electrical assets without requiring a time-intensive and costly service outage for setup. So without further delay, thank you, Daniel, for joining me for this episode of Energy Talks.
Hi, Scott. Nice to be here.
Daniel, we're talking about partial discharge testing and monitoring. There are various ways to look at partial discharge activity in electrical assets: offline PD measurements, online PD measurements, and PD monitoring. Is there a particular method that is most used in the industry?
Well, historically, the offline measurement is the way to go. But nowadays, we are seeing more and more the tendency to use online measurements or to go for monitoring of electrical assets.
Okay. Now, you mentioned offline PD measurements are often the way to go. Could you explain that?
Well, as I said, historically, the PD measurement has its basis in the research of dielectric insulation material behavior. And that is, of course, a laboratory part. First. Second, offline measurements are much easier. I have a very controlled environment, so I have multiple ways to actually vary my test parameters to get the most information out of my measurements.
Okay, and what types of information are you looking for?
Well, we are looking at the behavior of the insulation material under voltage or stress, or under the stress of an electrical field. Means if I raise the voltage, if I go to my nominal stress, I want to see, does the insulation material create any discharges which I'm not expecting? There are different materials. Some materials, as are used for cables, XLPE, they shouldn't generate any discharges at all because they are very sensitive to discharges. Other materials, like the ones which are used for insulating of rotating machines, are very robust to discharges. So they're just from how the material is built. I'm expecting a certain type of discharge, but of course, I want to see that these discharges behave within the limits.
Okay, so really what you're looking at is the integrity or the strength of the insulation and how much it can take when in operation.
Exactly. We want to see that the electrical insulation behaves like it has been designed, so that it holds the electrical stress, that it's not having any effects like discharges, which might shorten its lifetime, that there are no production or manufacturing issues which might impact the electrical insulation.
Just to be clear, when you're performing offline measurements, you are literally working with a piece of equipment that is not in operation, but to test it, you're actually injecting a voltage source and increasing the level to verify whether PD activity appears at a certain area or level.
Exactly. So if we do an offline measurement, we have our electrical asset, we have a separate voltage source, and we use that voltage source to energize the equipment. Of course, this is hardly ever realistic energization because most of our electrical assets out there are three-phase assets. Most of our voltage sources are single-phase sources, which gives you the idea. Of course, we just stress certain parts as they should be, other parts not. Well, with an online measurement, I have the asset online, so I have it in operation like it should be. It's connected mostly to the grid and sees the electrical stress as it would be during its normal lifetime operation.
You mentioned that there's a trend to do more online PD measurement and PD monitoring. Could you explain that?
Well, first of all, we have an increasing number of what we would call critical assets. There can be different reasons why an asset is critical, as you have different viewpoints on an asset. It can be critical from an operational point of view. For example, I don't have a backup for that asset. Replacement is like hard or impossible at the moment. There can be let's say, commercial point of impact, like the asset is just very valuable, so I want to keep it operational and in good shape as long as possible. And last but not least, of course, there's also let's say, from the operator's side, if an asset fails, it might have an economical or a reputational impact. There are different views why an asset is critical, but nevertheless, we have an increasing number of critical assets. And from the asset owner's point of view, I want to get more and more information about my asset to, when do I do maintenance? Which maintenance do I need to take? How can I put my limited resources on the asset which needs it most? And this together paves the way that we see more and more online measurement of assets or monitoring, as, of course, it's easier. I don't need to have the asset offline. It can be in operation. I don't need a second voltage source in the ideal way. I just go there and have pre-installed sensors and can connect my measurement equipment or my monitoring equipment and have a look. And then I move on to the next asset. So in the ideal way, I have a very easy approach to gather information about my asset.
And of course, a lot of asset managers and utility operators prefer to keep their equipment online as often as possible without unnecessary downtime. The online measurements, of course, facilitate that, allow you to do the testing and or the monitoring without having to take down the asset and to keep it in service.
Right. I mean, as soon as I take down an asset, it's not operational anymore, and it's just costing me money, and I'm not earning money with it. All the operators operate on an economical basis and need to make money.
You had mentioned that when you're doing an online measurement or monitoring, you're working with pre-installed sensors. That means you had an initial downtime, maybe a regular scheduled routine maintenance downtime where you installed those, and then after that, you don't have to take the system down to do any setup. How are you connecting the measurement or monitoring equipment when you're doing these online measurements?
Yeah, exactly like you mentioned. So, of course, there needs to be an initial downtime, which is preferably just matched with any maintenance period, which is there anyways, to install the sensors, as the sensors somehow need to have a connection to the high voltage part, so you can only install them while the asset is offline. And then we normally connect these sensors to what we call a terminal box. This is a box which is installed at the asset or in close proximity to the asset in a position which I can access while the asset is online. And here the sensors are connected and they are terminated in a safe way so that independent of the asset's operations, I can go there, I can open that box, I can connect my temporary monitoring device, or I can connect my diagnostic measurement equipment, and I can perform a measurement. And after I'm done, I can disconnect everything and just close the box again, and the asset in a safe state, and also my working with the asset, with the connection, is in a very safe environment.
Now, you mentioned diagnostic and monitoring. There's a difference there. Could you describe that difference and how they're used together?
Of course. Classically, we did diagnostic measurements because, as I said, we wanted to get more insights about how a material behaves. But when we look at an asset which is operating 24/7, I want to see how does the asset or how does the installation of this asset evolve. So what I do is I have a monitoring system connected to the asset, which I use to do regular measurements with the very same settings. So same frequency, measurement frequency settings, same bandwidth settings, same amplification, whatever. I have more or less pictures in time where I see how does the installation of the asset behave. Or now I see a trend. Do I see like an increasing trend? Is it like stable? And this gives me the insight, is there something happening in the installation or is it just operating as normal? That's the monitoring part. And here it doesn't really matter. We can distinguish, if we want to look deeper into it, we can distinguish between temporary monitoring and permanent monitoring. You connect a monitoring device to your terminal box, which is connected to the sensors, and you do a recording session, for example, a week. And then you have a look at that session, you move on, you can use the very same device to look like at the next asset. And then after, for example, half a year or a year, you return to your first asset, you do the very same again, and you have the comparison in time.
So you're essentially installing one terminal box at each asset and connecting it with sensors permanently installed on that asset.
Exactly. At each asset, I have my sensors installed. At each asset, I have these sensors connected to a terminal box. And then I'm just moving around with my monitoring system, one asset to the other one, measuring or monitoring for a certain set period, like a week, 2 weeks, as it's preferred or as it's also applicable for that asset. While with the permanent monitoring, I have a monitoring system installed at that asset, which is really monitoring 24/7. It sees kind of every second of the lifetime of the asset and can give me a much more complete look because I'm not missing out anything. On the other side, as you can imagine, it's much more expensive to install something like this. This is really an economical question. How critical is the asset? Do I want to go for like a permanent monitoring? Do I want to go for temporary monitoring? The big advantage of the terminal box, and we'll get to the diagnostic measurement in a second, is of course, if I see that an asset is like more important for me as operator or as asset owner, I can of course also connect a permanent monitoring system to a terminal box. So also there, the switchover doesn't involve any changes at the asset anymore. Our terminal box is designed in a way that you can actually connect the permanent monitoring system and keep the terminal box, keep everything installed, just connect the system and have it then monitor 24/7. Now you asked, what's the diagnostic measurement? When I have an asset which I'm monitoring, no matter if permanent or temporarily, and I do see some effects, for example, a rising trend. I do see some patterns which cause alarms. So I have an initial clue. Then I can use a diagnostic system. There are some, as we call them, diagnostic monitoring systems or a diagnostic measurement system, connect to the very same sensors, to the very same terminal box, and now have an in-depth look. In contrast to the monitoring, I have a measurement system where an expert is sitting in front who can then adjust measurement frequencies, who can use all the nice tools we have to really distinguish different types of PD and have an in-depth look and maybe tell you as an operator, here, there seems to be an issue, I don't know, at this end winding of the machine, and you should have a closer look here. And then we go from there. That's kind of the online diagnostic measurement. And depending on the outcome, you will eventually move to an offline measurement because, as I initially said, big advantage of offline measurements is that you have much more freedom in controlling your environment. So you have even the possibility to look more detailed on a certain part you want to look at.
Okay, so you mentioned earlier that online monitoring and measurement diagnostics can be done, of course, when the system is up and running, and it also helps you to identify critical assets that are critical to the operation and also may have a history of problems that need to be monitored or looked at closely, and then giving maintenance engineers the ability to decide which piece of equipment requires maintenance. And then that would be the time when you make the decision, okay, it's clear this particular asset that your operation is not affected has an issue that we really need to take a deeper look into. So that's when you would probably take it offline and make arrangements by that outage.
Right. You described it perfectly. Like the first indication would be by an online monitoring. I do see something which, like, let's say, raises my interest or seems to be suspicious. And then as a next step, I would have a deeper look with an online diagnostic measurement to really identify how critical is it. And then, depending on the outcome, you would arrange for an offline measurement, maybe also other offer measurements beside PD, which can only be done offline, and really have a very detailed look on that asset, which, as you also explained, like, has a huge impact on the operation. As you take the asset out of service, you have like a bigger impact in terms of manpower and in terms of material you need on site. So it's much more complicated.
But the information that you gathered really helps you to focus on exactly what you need to do, rather than a lot of guesswork and maybe taking down the wrong assets when they could be kept running.
Yeah. The idea is really to kind of narrow down from different things which might happen, like disturbances, wrong alarms, to really narrow down and focus on the asset which needs the focus, where all this effort is put to a good place.
Okay, so again, it's enabling you to focus on a condition-based maintenance, a condition-based investigation.
Yeah, that's the keyword. That's what we use a lot. Exactly. Normally, we had a time-based maintenance and time-based investigation. Every X years, you would do a maintenance on the asset. With the limited resources, you move more and more to this condition-based maintenance, where you really have a look at the condition of your asset, and one of these parameters you take into account there is PD, and decide based on the conditions, what is the asset I focus on next? So where do I need to have a look? What can wait? How do I separate, and how do I really put my resources I have to work at its best?
Okay, very good. Now, you mentioned there are other measurements that you can do, especially when the asset is offline, other offline tests to take a look at the dielectric insulation condition. Would you still consider the PD test or diagnosis to be one of the most important? Or do you see these measurements working together that can help you understand what is going on?
Yeah, I wouldn't go so far as to put the PD measurement as being the most important. It has the very huge advantage that it's a measurement which you can perform online. You have the possibility, if you have sensors installed, to do at any point in time and get information about your asset. Well, there are other measurements which also add to the picture and help you to identify and also assess the risk of an asset failure, but they require the asset to be offline. I often like to compare that to a doctor's visit of a human. Normally, you won't enter to your doctor, have him get your blood pressure and ask him how long you will live. Like, you will do multiple tests and he will like complete his picture. And with this, well, he might also not tell you how long you live, but he will give you an idea about your health status. And that's the same with an electrical asset. Like, there is no single test which actually gives you the information about the health status of an asset. They're just different tests, and they can be utilized in different situations, and altogether, they give you a good image. Now you ask about other tests. This is really much, or really depending on the asset. I mean, for example, for rotating machines, there are tests which give you an information about how the insulation behaves as a whole, like this PI test, tests which gives you an idea about how the magnetic flux is distributed over the machine. So there are several tests depending on assets, and altogether, as I said, give you a good image or a good picture about the health status.
It would interest me to know, when you're doing online tests and monitoring, many assets are inside in an enclosure, some are outside, like transformers or cable terminations. Does it matter whether you're inside or outside? Can you perform these measurements in both settings? Are there any particular considerations to make when you're doing these measurements and monitoring outdoors as opposed to indoors?
Of course, weather might come into play there. In general, it doesn't matter if your asset is inside or outside. What matters more is how, let's say, your electrical environment is. If there's a lot of disturbances, it will be much harder to get like a good and solid online measurement done than if there are only a few disturbances. But this is independent of inside and outside. Of course, if I do measurements, let's stay with your transformer example, and it's heavily raining outside, this will create disturbances on the bushings, and this will impact my measurements. To a certain extent, we nowadays have tools to do a good noise separation, but also these have limits. For example, really too extreme surface discharges on a bushing, maybe after rain, you will run into limits and you will lose sensitivity. Nevertheless, in general, it doesn't matter. You can do this outdoors, you can do it indoors, and you will get the same or results.
The terminal box is in a protective housing, so in many ways that does help protect your connections in an environment.
Yeah, the terminal box is in a protective housing, so as long as the terminal box is closed, well, it's quite clear, all your connectors are protected. But we designed the terminal box in a way that it's also possible to have it keep its IP rating even if you have connected a measurement device. I mean, that's not so much of interest if I use it for a diagnostic measurement, because as I said there, I have an operator sitting in front, so normally you want to protect that operator as well. Not so big of an issue. But if I use that for a temporary monitoring session, well, nobody is sitting in front of the asset for a week. So they're much more interesting that I can actually connect my monitoring device, close the terminal box again, and have it keeping its IP protection level so that I can leave it there and have it monitoring without needing to fear about my equipment.
Daniel, you mentioned there is a number of tools that help to filter out noise in particularly noisy or disturbance-laden environments. Could you please describe these tools and how they work?
Well, we have the possibility to choose our measurement frequency, so the center frequency band, which allows us at first to really look for a frequency spot where we can get the best out of the measurement. 3D images where you have multiple things printed over each other and you have colored glasses to look at them. This is a little bit how you can imagine a frequency selective measurement. You're just looking through one of these glasses, so just to the green one, and you can see a picture, while before it was all strange and mixed up. And a frequency selected measurement is going the same way. So that's one of the tools. The other thing is, as soon as we measure with multiple sensors, like with 3 sensors, we have the possibility of using a so-called 3-part, which is analyzing the cross-coupling between the sensors. And that's a very powerful tool. As you can imagine, if I have any kind of signal, which happens, and it will propagate through my asset, through my media, to my sensors. And wherever that signal originates from, it will propagate always the same to my sensors. So if I have one signal, well, that propagates a certain way. I have another signal, for example, a disturbance, it will propagate a different way. But every signal, every disturbance which comes from that point will propagate in the same different way. So at the end, I have the possibility to really look at the different, let's call it, signal distributions on my sensors, and with this separate sources from PD or X disturbances. So I can distinguish between different sources and can have a look at them again.
How do you determine if you have a defect or an issue in the installation? Can you determine what's causing it using the diagnostic PD measurement?
To a limited extent, yes. What we use as a tool is the visualization. Let's say that's industry standard. We work with so-called PRPDs. Means we look at the different discharges, which is just kind of a peak in time, with respect to the AC phase, which is applied. And that gives you what we call a pattern. They give us an indication about what kind of defect it is. So are we looking at a surface discharge? Are we looking at something which is internal to the material? Are we looking at a sharp edge in air or in gas? So we get a first idea of what it is. And then with the knowledge background of the asset, you can actually track down a lot of this information to individual points in the asset. Yeah? If you look at a rotating machine, there's a certain way the machine is built up. So you know that certain kind of defects will happen, for example, at the end winding, this, together with the information about what kind of defect it is, will give you a very good indication where you need to look at and where you need to focus if you want to look for the source of the defect.
Do you see any particular trends that are going in the direction of online monitoring and PD diagnostics in the future?
It is definitely increasing. Asset owners want to have more information about their asset all the time. There's an increasing trend to build so-called asset health models to really get an overall information about what's the health status of my asset, how long does it still live, what's the remaining lifetime, when do I need to do maintenance, and so on. And PD monitoring is one of the input parameters for these health models. And as I said, the advantage of PD monitoring is that it's one of the input parameters which I can actually create continuously. So I can monitor and I can feed values or alarms into the model and can get a very good picture. On the other hand, you have more operators not having any detailed expertise about assets anymore. So they have a very limited resource. And also here, PD monitoring with the abstraction of alarms and reports can help you to use your limited resources and expertise to really cover your whole asset fleet and get the best information about your asset status.
Well, Daniel, thank you very much for your time and wonderful insights into online PD measurement and monitoring.
Thanks, Scott, for having me.
And a big thank you to our audience for listening to this and other episodes of Energy Talks. We always welcome your questions and feedback. Please send us an email to podcast@omicronenergy.com. Omicron has several years of experience in power system testing, data management, and cybersecurity, and offers a matching solution for your application. For more information, visit our website at omicronenergy.com. Please join us for the next episode of Energy Talks. Goodbye for now, everyone.